AI applications now fail in new ways. They choose the wrong tool or leak sensitive context. They drift from policy or give misleading answers. Logging captures every model interaction as evidence. Monitoring turns that data into actionable insights. Evaluation metrics measure trust and performance. Without evidence, production Claude systems are black boxes. They appear confident but lack transparency. The winning teams can see what's happening under load. Traditional observability was built for deterministic software. A 200 response doesn't guarantee a correct answer. Low latency can mask weak retrieval quality. Clean server logs hide unsafe tool choices. Silent refusal remains undetected. Modern AI teams must monitor behavior, not just infrastructure. The bottleneck is no longer uptime. It's about whether the system deserved trust under real user pressure. At production scale, this becomes a product problem. The cause is architectural. One user request travels through many layers. It passes through prompts, documents, and model reasoning, then tool calls, approvals, retries, and final formatting. Each step may succeed locally, but the entire workflow can still fail globally. If logs only capture the final response, the most critical failure is already gone. You cannot debug a system you only see at the exit. That missing middle is dangerous. The breakthrough is treating every AI request as a traceable execution graph. The prompt becomes an input span in the trace. Retrieval turns into evidence within the flow. Tool calls become auditable actions. Model outputs are scored artifacts. User feedback becomes signal, not just opinion. This shifts observability from after the fact debugging. It transforms into continuous product intelligence. Failures become training material for safer systems. Sharper models emerge from this insight. Engineers gain real leverage. Traces show the path requests take through systems. Metrics measure runtime behavior and performance. Logs record important events and system activities. Baggage carries contextual data across services. AI observability adds evaluations to the stack. Trace the path of every request. Measure the cost of each operation. Log every decision made by the system. Score the outcome of AI-driven actions. Preserve context for later explanation. That explanation becomes governance. OpenTelemetry enables this entire workflow. The production log is not a text dump. It is a structured record of key details. Each entry includes request ID and user segment. Model version and prompt version are tracked. Retrieved sources and tool schema are logged. Tool input and output are recorded. Latency, token count, and refusal state are captured. Safety flags and user feedback are included. This envelope enables teams to replay behavior. It protects sensitive data while preserving context. It serves as an audit trail for every decision. Every automated action can be traced back. Monitoring becomes useful when every layer has a question. Did retrieval find relevant context? Did Claude select the right tool? Did the tool return valid data? Did the final answer follow policy? Did the user accept it? Each question becomes a metric. Each metric becomes a release gate. Dashboards stop being decoration. They start controlling deployment risk. Risk becomes measurable before launch. Core workflow is a closed loop. Instrument production to detect anomalies, inspect traces, and label failures. Promote successful examples into golden datasets. Rerun offline evaluations regularly. Block regressions before deployment. Claude Console supports test cases. It handles CSV imports and quality grading. It also manages prompt versioning. The loop gets stronger with real production traces. Reality becomes the test suite. Under pressure, it evolves. Tool monitoring needs its own dedicated surface. Agents interact with external systems through tools. Log every tool selection and parameter used. Track permissions, retries, and partial JSON responses. monitored downstream errors and irreversible operations. Anthropic observed common failures include wrong tool selection. Incorrect parameters are frequent too. This is especially true with similar tools in large libraries. The key metric is not usage, it's tool correctness. Actions require stricter accountability. Quality metrics must distinguish system health from answer quality. Track P50 and P99 latency, token usage, and cost. Monitor error rate, throughput, task success, and faithfulness. Assess relevance, toxicity, refusal accuracy, and escalation rate. Human correction rate is also critical for evaluation. A fast hallucination is not a success. A safe refusal may be the correct output. The dashboard must reward truth, not speed alone. Reliability requires both performance and correctness together. LangChain evaluation is hardest when there's no stable ground truth. Production LLM apps need use case specific evaluations. Accuracy, relevance, coherence, toxicity, and safety matter. Most combine code checks, LLM as judge methods, and human review. The right metric predicts product risk. Generic scores feel precise but aren't always useful. Calibrated metrics become operational leverage. Evidence beats aesthetic dashboards. They expose what actually matters. The future production Claude team doesn't rely on anecdotes. It reads traces and compares prompt versions. It audits tool behavior and watches feedback drift. It promotes real failures into tests. Logging tells what happened. Monitoring tells when it changed. Evaluation tells whether it was good. Together, they form the control system for trustworthy AI. They turn uncertainty into an engineering surface. Visibility becomes a competitive advantage.